Hey everyone, hope you're having a great night. Today we are going to talk about how we use magnets to create electricity. We've talked about electricity, we've talked about magnets. Today we're going to merge them together and we're going to show how they relate to one another. And there's a lot of similarities that we've talked about. We've talked about how protons and electrons are a lot like the north and the south end of a magnet, in the fact that a proton has a positive charge and the electron has a negative charge. A north end of a magnet and a south end of a magnet have opposite charges as well. And so there's a lot of similarities between those two ideas. And today we're going to talk about how they can work together to create electricity. So the first type that we're going to talk about is an electromagnet. And the way you make an electromagnet is you take an item that has magnetic properties to it. So you have like a nail. Now, a nail is not magnetic in the fact that it's going to attract other things. If you brought a magnet near a nail, it would be attracted to it. But the nail itself is not a magnet. Now, the way that you can make it a magnet and you can make it attract other things is by wrapping a wire around it. And you hook those ends of the wires up to a battery. And like we've talked about, in a closed circuit, the electrons flow from one end of the battery to the other, and they travel through that wire. And as they travel through that wire, they magnetize the nail. And so the nail itself becomes a magnet, and it's able to attract other materials for the period of time while it's connected. Now, as soon as you break that circuit, and it's not a closed circuit anymore, it's got an opening in it, the nail will not work as a magnet. And you can see how using electricity can help to create that magnetic effect. Electromagnetic induction is kind of a similar thing. It's where you make an electric current by moving a magnet and a wire in a loop. So you kind of move them around one another and you use their different properties or their different attractions to create this field of magnetic induction. And it's just like when we talked about charging by induction, you get a rearrangement of the electrons, and that can help to produce electricity. So when we're talking about making electricity, there's many different types of power plants, but almost all power plants have a generator. And a generator is where it converts mechanical energy, and mechanical energy is a form of kinetic energy because it's movement, into electrical energy. And it's able to change that moving item, whether it be water or steam, into electricity for people to use. And there are magnets in a generator that spin, and I'm going to show you guys a little bit of a video in a couple minutes here that'll show that whole process. And in the power plants, like I said, we have generators, but power plants are a source for electricity. We do not have ways of making electricity without having a power plant to supply that. And so by using the different types of energy to give different generators their ability to create electrons, we're able to get electricity, whether you're talking about burning coal or natural gas, or there's a lot of different power plants starting to use renewable energy sources where they want to use solar power or wind power or geothermal, warmth from the ground. And so we use all these different things. They all involve the same idea though. You use kinetic energy from something moving and you convert it into electrical energy. And it seems like maybe it's this huge crazy process, but it's not too bad. I'm going to show you, it's about a 5-minute video. Check this out. It really helps you understand what's going on.
Here's a question for you. How many people does it take to turn on a light bulb? The answer seems simple. Just walk into a dark room, flip a switch, and instantly you can see, right? Well, the truth is there's a lot more to generating and delivering electrical power than you've probably imagined. Hi, I'm Lee Patrick Sullivan with Energy Now, and this Energy 101 video explains the system used to generate electricity. And it also explains what it really takes to turn on a light bulb. In order to understand energy, we first need to start at the source, literally. Mother Nature provides the natural resource we use to generate power. From natural gas to coal, ocean tides to mountain winds, the energy we need to create electricity must first be mined, harnessed, or collected from the earth. Some of these resources are finite, including fossil fuels like coal and oil, but others are unlimited, like solar or wind power. But a lump of coal or a strong breeze alone won't create the power that turns on your light. For every energy source, a chemical or mechanical process is required to turn it into usable electricity. Every day, researchers work to find innovative ways to use our limited resources, process raw materials, harness renewables more efficiently, and find entirely new energy sources. Today, the majority of America's electricity comes from thermal power plants. Fuels like coal, natural gas, biomass, and uranium are used to heat water until it produces steam, which powers a turbine and generates electricity. That steam turns propeller-like blades around a rotor inside the turbine. This turning rotor connects to a main shaft which spins magnets with a coil inside a generator. It's the generator inside a turbine that converts mechanical energy into electric energy and creates electricity. Steam is an efficient method of producing electricity because the water can be recycled and reused as it changes back and forth between liquid and gaseous states. Transporting electricity from the power plant to your home is an entirely different process. Current technology cannot cost-effectively store large amounts of electricity, so significant challenges exist when it comes to transferring that electricity across long distances. Just enough electricity has to be generated to meet demand at all times and be transmitted through power lines to reach your light switch. Too much or too little power can crash the transmission system and cause a blackout. That's why a complex mix of logistics, management, and infrastructure is needed to transmit electricity from power generators to consumers. Enter the electricity grid, also known as simply the grid. The North American electricity grid is actually made of 4 large grid systems: the Western grid, the Eastern grid, the Texas grid, and a grid covering the Canadian province of Quebec. These independent regional networks of power plants and transmission lines carry electric energy at high voltage within
Remember,
their
these are
area
just electrons
to local utilities.
zooming down through the wires.
There are very limited links between the 4 grids, which means electricity generated from a wind turbine in West Texas cannot reach an apartment building in New York City. For electricity to move through one of the 4 grids, its voltage must first be increased by a device called a transformer. Then the electricity can travel long distances across high-voltage transmission lines. These high-voltage lines are generally strung between giant metal towers. They stretch for miles from power plants to local substations in each neighborhood. You've probably seen substations along the side of the road and wonder what they do. Well, their job is stepping down electric voltages from levels as high as 765,000 volts closer to the 110 volts you use in your home. The electricity from the power line on your street passes through another transformer, which steps down the voltage once more, and then it travels along the line into your house. From there, the electricity enters your breaker box, and it is then distributed to light sockets and outlets. All you have to do is flip a switch. So, as you can see, from the raw materials to the power lines on your street, there's so much more to the electricity ecosystem than meets the eye.
So you can tell there's a lot that goes into producing electricity, and it wouldn't make a whole lot of sense to send all the electrons from a power plant directly into your house. So it goes through some different stages and kind of slows it down. Now where the magnets come in is back in that generator. When they're spinning that magnet around, that allows the electrons to travel through that area into a wire, and that goes outside, and that's where we get our distribution of electricity from. All right, hopefully that clears it up a little bit so you guys kind of understand how those two things work together. As usual, we'll do a little more work in class, help you understand. You guys don't forget the quiz on the back. Have a wonderful evening. I'll see you all tomorrow.